how much money must be invested in an account earning 4% interest per year, compounded quarterly, in order to have $10,000 in 10 years? We're going to use the same formula that we've been using for compound interest. But in this situation, instead of trying to solve for A, we're going to want to solve for P, because they're asking us how much we must invest, so they're asking us for the principal. So we're told that we want to end up with $10,000, so that's going to be the amount. We don't know the principal. We're told that the interest rate is 4% per year, that's 0.04, and the number of compounding periods per year will be 4, because we're compounding quarterly. And then for the exponent, we've got n, which is 4, times t, which is 10, so that ends up being 40 in the exponent. So what I'm going to do is I'm going to simplify this expression on the right-hand side. 0.04 divided by 4 is 0.01, and 1 plus 0.01 is 1.01. And then in the exponent, 4 times 10 is 40. So we've got 10,000 equals P times 1.01 to the 40th. And if we want to get P alone, we need to divide by 1.01 to the 40th power. And so the value of P is given by 10,000 divided by 1.01 to the 40th power. And if we use a calculator to figure out what that is, we end up with $6,716.53. So that's how much we would need to invest in the account if we wanted to end up with $10,000 10 years later. Very quickly, the reason why I didn't do the approximations until the very end, I actually had exact values here up until this point, is because if we get an approximation for this value here, for 1.01 to the 40th power, even if we keep 4 or 5 decimal places, we will end up being slightly off with the final answer. It might only be a matter of a few cents, but if we want to really be sure that our answer is correct and all of the digits that we're giving are correct, it's important to not do any of the approximations until the very end. And if we had taken 1.01 to the 40th power, we end up with a really, really long decimal number, and we would more or less have to do an approximation there. So it's better to keep exact answers until the very last step.